कैसे करती है
थोड़ा सा सिखा सर बोलेंगे
आज का रिकॉर्डेड लेक्चर देख ही नहीं सकते ये वाला चैप्टर कंप्लीट अभी चौथा है ये थोड़ी इतना अच्छा है प्रोबेबिलिटी से प्रोबेबिलिटी से नहीं को मैसेज हेल्प नहीं करता तेरे को और तो उस पे को होएगा तो क्या स्कॉलर है ठीक है बस मुझे देखना बहुत सारी बात डाउट सॉल्व नहीं देता हूं एक दूसरे का सॉल्व में से बचाव है फर्स्ट डाउट सॉल्व ऑनलाइन लेके आना है थोड़ा नेक्स्ट जब आने वाला है पूजा पाठ तेरे आज में जल्दी जल्दी होगा बाकी सब तो फिर बाकी सब में मौत है अरे उसको मत तुम लोग का पावर एनर्जी चालू है पावर एनर्जी सिर्फ बहुत मेरा राइट हमारा लोगों बड़ा है तो सीआई के लिए भी क्या बात है हमारे जो टैक्सी है वो लगे लग रहा था हां ये टैक्सी वो ना तो डुप्लीकेट टैक्सी पार्टी डुप्लीकेट आएगा द टैक्सी ये सब में आप लोगों ने उसको मुझे सीरियस इसका टैक्सी ये भी अच्छा बात नहीं है जैसे कि लगा के किसी में कल को भाई
मराठी मूवी जयजय काय असे यंगस्टर आले ना असंच प्रॉब्लेम होतो असाइन पटपट चला पटपट झाला त्यामुळे तुझी पण पुढचे एक्झाम आहे पटपट नाही चाललं तरी चार्जिंग मूवीला आता नाही तर तुला पुढे नंतर डिसेंबर माझी स्टोरी लाईक बघा हो सगळ्यांची स्टोरी आहे स्कूलची तू गोवाला कधीतरी तू टाइम होते का पहिल्यांदा हेल्मेट टाकलं टाकलं तुझं विचार पण नाही मस्त ना ज्याने पोस्ट कोणी काय माहिती तुमच्या शाळेत असतं तू जायचं का फक्त हे करायचं अरे नाही तू शाळेत करायची तर त्याची डोळे वेगळं करायचं मी एकदाच बघितलं तिला माहिती सगळ्या मला थोडं आवडलं पण मग इथं जेवण दाखवायला पाहिजे म्हणजे वॅक्सिनेशन किंवा शेडवॉल मला साधीच नाही आवडत तुला कसं आवडत नाही तेच ना बॅड चॉईस व्हेरी बॅड तू चल भाजी आपल्याला भाजी येतात ना अरे याचे तुला माझं पण दाखवून ये गाणं वाटलं ना
ये क्या खाते हैं ना बच्चे तो स्मेल आती है बाहर का दरवाजा खुला है हाँ थोड़ी देर खुलेगा
Yes.
That's good.
Yes.
You admission?
No, I went to change class.
You went to change class.
I was absent last class.
Last class. Anybody absent today?
Ria.
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 Ria. So where were we in the last class? We have finished the chapter, right? Machines. Numericals.
So we started with refraction.
We had already started.
Yes, we completed.
We complete first chapter. Already. Did we do refraction through glass slab?
No, sir.
Principle of reversibility?
Yes.
Okay. Did we do factors affecting refractive index of the medium?
Yes, sir.
Factors affecting?
Yes, yes.
So what are the factors? Temperature, nature of the medium,
The density.
Okay, so we have done that. So today we'll start with refraction through glass slab. Is everybody in? Is the strength less today? I see some students missing.
One action.
Only one absent, huh? Okay, let's begin with refraction through a glass slab. So this is volume page number 59. So refraction of light through glass slab. Is it visible at the back? Okay. So what is a glass slab? Any piece of glass. Okay. So you are seeing the front of it, right? Like if this is a glass slab, imagine this is a perfect cube. Just chop this off. Then it will have a cuboid shape, right? What you are seeing is the front part of it. Okay. So we are doing an experiment where we have kept the glass slab on a table like this. Okay. And this is white chart paper on which we have kept. Then here we have drawn a line, right? What kind of line? We have drawn a line like this. Okay. And we have inserted 2 pins over here, right? So where are our pins? Our pin, one pin is here, one pin is here, okay, on that line. Now we are trying to view that pin from the other side. Pay attention. Is everybody able to see this? So those who are not able to see, stand up and see. 2 pins here, right? And from the other side, I am trying to look at the pin, right? So when I am trying to look from the other side, okay, so then you take 2 pins again. So you try to insert it in line with the first 2 pins. Okay. So what is seen is, it is seen that I have inserted 2 pins here. Right. Now I join this line. Okay. When I am seeing these 2 pins, when I inserted, when I remove, I will get a hole, dot. I will join that. Okay. So this is how I get the line. Now when I join these 2 lines, this is what I get. Right? And this is understandable, right? Because when the light enters from this side, it is entering the glass media, so it should suffer deviation. Right? So this is angle of incidence. This should be angle of reflection, and it should bend towards the normal. Correct? And when again at this edge, when it comes out, so when it comes out, it will come out with the angle of emergence. And when I extend the original direction, what do I get? Right? I get a parallel line. Okay? So the diagram in the volume is not accurate. See the book diagram. I get a parallel line. right? So if this is A, B, C, D, has everybody understood how the refraction is taking place in glass slab? So what are you observing? Where are the refractions happening? At the edge AB and at the edge CD. Why? Because there is change of medium. You have air here, then you have glass here, then you have air again. Right? Where is rarer? Glass is denser. Again rarer. So this change of path of line is along the expected lines, right? So whenever light enters from rarer to denser, it bends towards the normal. Whenever it exits from denser to rarer, it bends away from the normal. This is what we learned, right? So what is the conclusion? What are the observations? So whenever refraction of light takes place through the glass slab, we find the angle of incidence and the angle of emergence are same. Okay. What does this mean? This means there is no deviation. No deviation. Okay? Between the emergent ray and incident ray. This is what it means, right? Why it will be same? Because the pair of medium is same. So amount by which the ray deviated or went toward normal, by the same amount it will go away, right? And only due to deviation within the medium, there is a lateral shift. So this is called lateral shift, right? So there is no deviation, just the lateral shift. Second observation is, so you can combine this as both of them. Therefore, there is a lateral shift between emergent and incident. Is this understood? So what is the learning? There is no change of direction, just lateral shift. Okay. What is the angle between two parallel rays? And what is the angle between perpendicular? How can both be 90? What is the angle between two parallel rays? No angle, right? Zero. So there are two lines. When I impose on this, both will just lie on each other. Is there any angle between this ray? So join the end, right? So when I join here, make a parallel. Now you have an angle. Right? So there is no angle between parallel rays. Okay? That's why no deviation. For deviation, there has to be some angle. Okay? So what do we say? It's only lateral shift. If I bring it over here or I bring it over here, then it matches. No angle. Clear? Sure. Because what is the incident ray? PQ. This is RS. Q dash N dash. So I have not labeled it, hoping that you know what is what. Right? What is ABCD? Glass layer. PQ? RS?
Emergency.
QR?
Refractor.
N dash?
Normal.
I? E?
Emergency.
Angle of emergence. R?
Angle of refraction.
Let me know once you're done. Everybody done? Have we done this? Real depth and apparent depth? Did we discuss floor of the swimming pool appears shallow? But did we do the theory? Shall we? So let us say this is the swimming pool. And this is the water level. Okay, what is it? This is the swimming pool. And what you see is the water level, right? So, what is the real depth? This is the real depth, which is representing by capital D. Okay. So now imagine this is the point at the bottom. We are calling it as P. So when somebody is looking from here, okay. So imagine two rays are coming out of this. One is going along the normal. So along the normal it will go straight. So we have seen that if the ray is along the normal, it will go straight, right? There will be no deviation. Now the second one, let's say right. The second ray is incident over here, obliquely. So this point we are taking, so there are so many rays, right? We are just taking two rays. Let's say it is incident over here. Then it is, water is a, what type of medium, rarer or denser?
Water
denser, right? Where is it going? In which medium? Air. This is air. This is water. So what should happen to the refracted ray?
Move away from the normal.
So it will move away from the normal. Let us say this is how it moves. Right? So these rays are shown quite diverse, right? But it is actually like this point would have been here also. Okay, straight and here. Got it? So the divergence is shown so much for clarity of the diagram, right? So where will this ray appear to this observer coming from? It will appear that it is coming from this point. It is coming from this point. So you will feel actual this point is not here, but you will feel it is here. So he feels that the depth of the pool is only this much. Small d. Got it? The observer outside the pool feels that the water level is only this much. Okay? But what is the actual depth? Capital D. Right? So D is the real depth and small d is the apparent depth. Apparent depth. Okay? So why the floor of the pool appears raised? Because of refraction of light. Got it? Now, let's find the relation between real depth, apparent depth and refractive index of water. This is refractive index of water. Right? Now apply the Snell's law at this point. Let's call this point as B, this point as A. So what is this angle? What is this angle? Angle of incidence. What is this angle? Angle of refraction. So here is refraction happening, right? So applying Snell's law at B. Snell's law at point B. Right? So what do we get? We get sine of I upon sine of R is equal to mu. What is the refracting medium? Air. This is what we get, right? Mu WA. Okay, everybody clear on this? Refractive index of the second medium with respect to first medium. The refractive index of the second medium with respect to first medium. That is how we had learned the definition, right? Mu. Okay, so far so good. This is our equation 1. But what is sine I? But sine of I is equal to, this is I, therefore I can write this as I, right? Alternate angle. And what about this? Corresponding angle. Okay? So what is sine I from triangle? Sin of I is perpendicular upon hypotenuse, AB upon EB, right? From triangle ABP or BAB. Okay. And sin R is equal to AB upon B dash B. B A B dash. Agree? So let's call this as 2. So therefore we can call, what do we call this? This we are calling as 2, both of them. So from 1 and 2. What do we have? We have W mu A is equal to sin I, that is AB on PB, right, into sin R, AB on B dash, right? So this goes, so therefore, and what is the relation? It will be 1 upon A mu W, right? You know this, right? Is equal to B dash B upon EB. Okay, so why? Since mu2 1 is equal to 1 upon 2 mu 1. We know this one. So if point B, so I said the diagram is very enhanced for clarity, right? But generally this point B is very close to A, because you are looking, when to see the depth, how do you see? You see like this. So you see down, right? So this point B and A will be very close, right? So assume point B to be very close to point A, right? So therefore P dash B will be PA, PB will be PA, right? Therefore P dash B is same as P dash A, and what is P dash A? Small d. And EB is equal to EA, which is equal to capital D. So if I assume that B is very close to A, then PB becomes equal to, PB becomes equal to PA, and P dash B becomes equal to P dash A, correct? So we'll substitute this in above. So let's call this as 3, this is 4. So from 4 and 3, so from 4 and 3, we get, what do we get? 1 by A mu W can be written just as mu W, absolute refractive index of water. This is equal to P dash B was D on capital D. Or what is the apparent depth? D is equal to capital D upon refractive index of water. Okay, the refractive index of water is roughly 1.3. So D, this will be less than capital D. Clear? Right now. So what is the shift? This is the shift. H. The floor is raised by H. That is D minus B upon.
not getting after that from 1 and 2. That's no, I was absent last class.
Huh?
After that, from 1 and 2.
What? So
Yeah.
from 1 you have sin I by sin r is equal to W mu A, right?
Yes.
So W mu A is equal to sin I. Sin I is AB by PB. 2 is both these equations. Okay. What is sin I? AB by PB. What is sin R? AB. So AB. So this is divided, right? So you have to multiply by reciprocal. Okay. So got this? AB cancelled. Then you get. Now there is a formula. This was not taught in last. Was it in last? Last to last.
I was absent.
Last. Okay. So then you have to see the video lecture. Okay, go through the video lecture. There is a relation. If you have refractive index of second, so you have to know what is the refractive index and all that. So go through the video lecture. It's a whole, I think, 2 hour session. Last class is divided into 2 parts: numericals for the previous chapter and the refractive. So second half onwards. Okay, you have to see the last video only, the last part of the lecture. Then you will get this. So for now, you understand if there is anything like refractive index, A and W, right? So once you take the reciprocal, the relation changes. Okay? You go through the video lecture, then talk to me, then we'll discuss. Because that's a lengthy explanation. So that's why I told you, like, try to avoid being absent for when any new topic is introduced. Because then it cannot be managed. See the video lecture and then we'll talk. So treat it as a mathematical simplification right now. Is it okay now? As of now? I am telling you, if this is taken as a reciprocal, then it changes. And when the first medium is air, then we don't write air. We just write the next medium. Okay? You have any problem here?
No.
So assume. You have to write B as A. Everybody done? How many you still writing? Raise your hands. 2. Take it. Can I start?
Yes.
So formation of multiple images in a thick plane glass. Is it possible to turn like this? No, it's not staying there. Let it go. Okay, so we have imagine you have a thick plane glass. Okay, so it is a very thick glass, right? And its back side is colored with a reflecting material like silver color. Okay. Now suppose you have an object over here. This is the object. Some object. Okay. So the light is incident from the object on the glass along the normal. So where will it go? It will go straight. Right? And let us say some more rays. Now some oblique rays. This one. And what will happen? This will be reflected back like this. So it will come back also like this. What happens at this point? So there are two surfaces to this thick glass. So there will be partial reflection of the light at this normal. Partial reflection in this direction. So equal. Right? This is the reflected ray, right? But some of it will enter the glass. So some of it is partially reflected, most of it will enter the glass. Where will it enter? It will enter like this. As the path changed, it has bent toward the normal because this is glass, right? This is air. Air and glass. Now at this point, what will happen? What will happen at this point? Reflection, because this is a reflection. Light can't go beyond this. So reflection is taking place at the upper surface at AB and at CD. Right? Refraction is happening while the light is traveling from AB to DC. From upper surface to. So in this part, refraction is happening. At this point and at this point, reflection is happening. Right? Now, so this is where it will be. Right? The reflected ray will be here. Now what happens at this point? It is traveling from glass to air. So it will be reflected away. So this is a reflected ray, whereas this is a refracted. Understood? Right. Now, there could be many more rays coming like this. So how many rays have been taken? Okay. चलो ये वाला है. So अभी इस surface पे क्या होगा? Refraction and there is a partial reflection, right? There will be partial reflection because every edge transmission maximum part only 4% reflection. Okay, but here now 100 here it is 100% reflection. There is no refraction here by the bottom surface. Okay, so at the upper surface you have reflection and refraction. For this case, refraction and reflection. Now here we'll just stop here the last ray. Again there will be just normal. What is happening? It will be refracted and it will be reflected. So on and so forth. Now see. So if somebody is watching from here, where will he see the image of this? Image of this object should be found somewhere here. Right? How many images will be there? Infinite images. Because this will just go on. Right? So where is the first image forming? First image is forming over here, where this extended line meets. So this is I1. Okay. Where is the second image forming? When you extend it backwards. This is your I2. Where is the third image? This should be parallel, right? Here it will come. So this is I2. What about this? Parallel. Somewhere. This is I3. And so on and so forth. Infinite images will be formed. ठीक है? समझ आया? Now the question is, which image should be brightest? Think and answer. I1 should be brightest. Why?
Because less light is reflected.
So it should be brightest or it should be lightest?
No, sir, I2 will be the brightest.
I2 will be the brightest. Now listen. When the optical information goes, one light, this is like fully reflected. Okay? Now what about this light? This is a reflected light. Reflection is partial. This is a partial reflection. Partial reflection. The partial reflection carries only 4% information. 96% entered inside. Now this is full 96% reflected. Now let us say 4% is reflected. So this is how much? 92%. So this second line, second light, and this one, the first one, they will form the brightest image. Got it? Everything else is reflected. Now once this maximum information is gone, rest are all due to reflection only. Got it? So in this you have to say second image is brightest. Image is brightest. Okay, so sometimes the question is asked on this, so you have to be able to explain it. Why the second image is brightest? Okay. Has everyone understood it? Okay, so read, and if you have any difficulty, you can ask me later. So this was the second application, right? So draw it. Take help in the book or so if you look at it, it's only straight lines, right? But at different angles. So you have to just don't mix the sequence. Sequence is first draw the glass, then choose one point, okay, one straight line from there, and dotted line below the glass. That's one. Then take one line oblique. Wherever that line hits the glass, draw a normal there. Then show the reflection, bending. Then draw a normal here. Then reflected, equal angle. Draw a normal there. Then reflected. This is parallel to this. Okay? And then this is parallel to this. Okay? Cross. So there is a technique. And then extend it backward in the end. These dotted lines you will draw in the end. From these lines, you just extend it backwards. Only draw about 3 lines. This is a wall or a wood? Wood. Wood. Second image is brightest. So the reason is this is the only refracted ray. Right? Fully refracted, right? Most others are, these are refracted, but these are refraction of reflected rays. But this one is refraction of refracted ray. Or refracted ray with max info. Refracted ray with maximum information. Just think about it. Except this ray, this is refracted ray. All the inside rays are reflected. Only this one is refracted ray, the first one. This refracted ray now fully, okay? Very small reflection. Done? So relax. This should be parallel. Okay, practice later, huh? But it should be parallel. Yeah. See the diagram for this. Volume, it will be on. Correct. This is our show. Okay? Everything. Where are the images? Yeah. So you should take it a little ahead, okay? So that your parallel will come down. This point is very close. But I think near the
Yes, sir. What error is coming from this line?
ये point थोड़ा सा दूर लो. तुमने thickness इतना ज़्यादा कर दिया है. So thickness should be less than this side, okay? Got it? The thickness of this glass. So the first point should be ahead of this. Then we'll get. Glass का जो thickness है ना. See, look here. This thickness. Now I have taken the point little here. So this point from the edge, this should be more than the thickness. Only then your image will come down. Got it? So with some practice you'll get it. Okay? So don't worry about it. What you have to learn here is, you practice the diagram later, you have to learn is why I2 should be brightest. I have given the explanation. Okay? Okay, let's move on to the next one. So don't panic if you are not getting the diagram right. Okay, practice later. Let's move on to the next problem. Have all of you learned the technique how to draw the diagram? First the rectangle. Okay, the point will be little inside. Don't keep this point along the edge. Keep the point little inside. Then this point which is hitting. So from the edge, this point, this distance should be more than the thickness of the glass. Okay, then your image will come down. Right? Okay. Next is apparent bending of the stick. So whenever you put stick in the water, it appears bent. Have you done that? Huh? Have you done that? You put your legs in the pool, leg will appear broken up. Okay, as a bend हो जाएगा. You can see that. So let's draw the ray diagram for it. So suppose this is the water level. Okay. Now suppose this is a straight stick. focusing on this part of the city. So when somebody sees from outside, let's say somebody seeing from here, what will you feel? So you take two rays, right? One will always be straight. So from the two rays, one will be along the normal. So incident. So between the two media, you have to show the direction. And second, you take as this. So this is the point, right? Therefore, this will be, you bend away. Right? This is angle of incidence, this is angle of refraction. So whenever it enters from water, so this is water, and this is air. Denser to rarer, it will go away from the normal. So what this eye will feel? This eye will feel that it is coming from here. Okay. Likewise, from all points, it will appear up. So when you join these, okay, this is where the stick appears bent. So when you put your legs in the water, your leg will appear bent upwards because of this. Got it? So same logic. If you see, the logic is same everywhere. So this is the actual point and this P dash. Okay? So raised depth, same thing, right? Likewise, there are so many other applications like stars appear twinkling. Star appears twinkling. Now, what kind of refraction? Due to atmospheric refraction. Right? Now, this diagram is not given in the book. Star appear. Do you see stars twinkling? Why it is so? See. Now, suppose you are standing here, right? And you have a star here. Now, Earth is surrounded by atmosphere, right? Okay. Now, the atmospheric layer density is lower upward. As you approach closer to the surface of Earth, the density of the atmosphere increases, right? So when the light enters from star, right? So it just goes on bending towards the observer due to refraction. So here you have a normal, so it will bend towards normal, and it is more denser and denser, right? It goes on bending towards the normal. Understood? Where's the duster? Let us say you have a star here. When the light enters the atmosphere, where is the normal? It will be towards the center. To the curved surface, what is the normal? The center. So now it will bend. But it is not just one layer, no? The density is continuously increasing. So it will go on bending towards the observer. Because normal at each point is changing. It is going on bending towards the normal. So where does he feel where the star is falling? He feels that the star is upward. This ray, he will feel that the star is upward. Understood? So the star appears above the actual position. The apparent position of the star is above the actual position. But atmosphere is not like water or glass. It is dynamic. It keeps changing. Okay? This medium is dynamic. So this position will go on going up and down, up and down. It gives the impression of twinkling. समझ आ गया? Why star appears twinkling? We just say due to atmospheric refraction. Likewise, sun rises before actual sunrise. What does this mean? And sets after actual sunset due to atmospheric refraction. This is not, the diagrams are not given in the textbook, it is just written over here. Okay, so but it is given in NCERT. So if you look at sunrise, let us say, when will you see the actual sunrise? When the sun is above the horizon, right? But what happens is, we have an atmosphere which goes on becoming denser towards the surface of Earth. Let's say sun was here in the morning, yet to rise above the horizon. But what about the sunlight? Now, where is the normal? Normal is towards the center of the Earth. So it will bend towards the normal. So, and everywhere the normal changes as it travels through the atmosphere, right? So the light will keep on bending towards the observer. Everywhere. Just after entering the atmosphere, it just keeps on bending towards the observer. So what does he feel? He feels that sun is already here. Sun is yet to rise, but he feels it's already risen. Okay, so he sees 2 minutes. He sees 2 minutes before sun is visible. 2 minutes before actual sunrise. Likewise, on the other side, the sun is already set, but it continues to be visible to the observer till 2 minutes. Okay, sun remains visible to the observer after till 2 minutes of actual sunset. It has already gone down the horizon, but our observer keeps on seeing it. So why is it happening? Due to atmospheric refraction. Understand? Can anybody explain twinkling of star and atmospheric refraction? So all these phenomena are due to atmospheric refraction. I mean, these two. And these are due to refraction. Change of. Okay. So you need not draw the diagrams. Okay, just read it. Likewise, print appears to be raised when glass slab is kept on the printed material, right? Tank appears shallower than its actual depth. We have done already. Okay. So we have 15 minutes, and I'll start with refraction through prism. Yeah, we did that, right? So here the matter is not organized, okay, in sequence. So follow what sequence I am giving. Okay. Now, are you writing it? Draw this diagram. This diagram. Third one again. See, the stick is inserted in water, right? So when you see it from outside, this point, how it will be visible to the observer? So we need light rays coming from the point, right? The light ray which comes from the point, here at this normal, it will go away, bend away. So what he will feel? He will feel that the light is actually coming from here, not here. So this appears bent. And the same thing is happening from light coming from all the point. तो वो क्या हो जाएगा? When you join all the lines, rays from all the point. अभी हमने सिर्फ एक point का ray लिया. When you join the rays, take the effect of rays coming from all the point, it will be lifted like this. Like ये वाला point तुमको यहाँ दिखेगा, ये वाला point यहाँ दिखेगा, ये वाला यहाँ दिखेगा. समझ आ गया? तो twinkling होता है atmospheric refraction of So anyone has attended Byju's class? You have attended Byju's class? How is it? Byju's?
I have taken the videos.
Huh?
I have taken the video thing, not the classes.
Acha, video thing. They have a physical classes also like us. Acha. So how are you finding their video things? Videos, they make nice videos, right?
Yes.
But is it helpful?
Yeah.
Then why here also?
9 and invited.
Huh?
9 and invited. 10 are not invited.
That's why I was asking, like, why did so this is for my curiosity. Why did you make a decision to join us?
Sir, actually, I had Byju's from a 6th standard, so it was like a package. So I had to take that. So if I'm joining this, then I have to see that.
So now that you have learned Byju's and now you're learning with us, can you? So what is the difference you feel? Where is learning more effective? Is it
in the
here?
class because we can interact.
So in Byju you can't interact. They don't have interacting.
We have, but
They
then
have
we only
to-
see the videos.
Acha, only do the video. Means it is whatever you can gain from the video, that is it. Means interaction is minimum. You can't
We
personally
have
gain the
ready-made. The video is ready-made, so we have to just watch it.
but like it's a linear thing. In between you cannot ask question. Or is it while you're watching the
No, we have.
lots of things are there. So where you actually get the opportunity to interact with the actual teachers. But then there might be so many students, because they have a big platform. So each student gets adequate amount of time,
As much as required.
as much as required. So they might be having large pool of teachers also. I feel it will be effective in smaller grades, not in higher grades. Because as you go in the higher grades, the level of just one concept explanation sometimes takes hours. वहाँ पे मेरे ख्याल से it will be difficult for them to manage. Anyways, it is now Mahesh tutorial, no? Not Mahesh. What was it? Akash. Akash is now Byju's, right?
Yeah.
That is just for IIT and NEET.
That is only for NEET mostly. Akash is mainly known for NEET. We also have champions. At Universal, we have association with champions for medical and IIT. So we can approach them. Which is a physical thing, not video. Champion is like run by an ex-IITian. Have you met him? Okay, are you done writing? Draw till diagram 3, 4th you just write these statements, 4 and 5. If you want to draw the diagram, you can do that also, it's just some curves like that. Should I start Prism or after the break? I guess after the break, 10 minutes. Have you done drawing the diagram or still drawing somehow? I will just draw the diagram for Prism. I will do the explanation later. Okay, because saturated already? Why? Saturated? Nahi na? Right. मतलब पॉजिटिव आंसर देना चाहिए टीचर को. ओके. So my suggestion is just feel free. Don't take stress. कहीं पे अटक रहे हो तो just feel free. I'm not your school teacher, so I'm just like your. I'm very approachable. Just feel free to ask. Don't be scared. So you have come here to basically kill all your doubts and concerns. Okay. Can I erase this also? All right. So now is next topic is refraction of light. So are you getting the sense of what is refraction of light? Because the same thing is repeating, right? So pay attention to our funda clear ho jayega. Refraction of light through a glass prism. Okay, so first of all, let us understand what is a prism. Have I defined prism earlier? No, right? So prism is a transparent medium bound by three rectangular surfaces and two triangular faces. Okay, what is a prism? You have so we have these two triangular faces. Okay, this is a prism. So A, B, C, D, E, F. Right? So what are the three triangular faces? Three rectangular faces. So rectangular faces are so you have A, B, E, D. You have A, C, F, D. Okay. And then you have B, E, F, C. Yeah. So this is the base of the prism. And these two are refracting surfaces or lateral or refracting surface. Okay, so the front face is ADFC and the behind is ABED, which is okay. And the triangular faces are what are the triangular faces? ABC and DEF. So Voyagers conduct tests also, like
After every lesson, there is a test.
there is a test,
Chapter-wise test.
chapter-wise test, which is like physical. You have to write and send, and they will correct it.
It's objective.
Objective, acha. There's no descriptive test.
For that, you have to ask them.
That's a different package. There's too many packages.
Not package, actually, you have to ask them that you have completed the topic. So they will tell you how to conduct the mock test.
They will arrange if you
Yeah.
insist.
Yes.
So they have centers everywhere.
I think so.
Or you have to send to Bangalore something by post. So triangular faces ABC and BA. Next is the ray diagram for refraction through prism. So I don't want to delay your break even by 10 seconds, okay? So tell me, patak se ki sir break ho gaya. Now see, when we draw the ray diagram for prism, okay? So we only show the front face. Okay? So ray is entering from the left rectangular face and it is coming out from the right rectangular face. Okay? समझ आ गया? So we only draw this ABC. Okay? So how do we draw the ray diagram? Everybody pay attention here. First we mark the midpoints of face AB and AC. Mark the midpoint. Okay? Draw the normal. Because for refraction you need normals. Okay? You have normal here also. So normal everybody understands perpendicular, right? So extend these normal and join them. Okay? So the normals are joined. Now incident ray is, girls pay attention. Where is the incident ray? At this point. So this is your angle of incidence. Okay? Then inside prism, where the ray will bend? Towards the normal.
Yes.
So if this is the incident ray, if it bends towards the normal, then it will become, it is bending towards the base. Okay? So I have given you a particular situation where the refracted ray will be parallel to the base. What is the situation of the refracted ray? Parallel to the base. And now the emergent ray will be
Away from home.
away from her. And for this situation, when the refracted ray is parallel to the base, that time the emergent ray is equal to the
Incident.
angle of incidence.
Sorry,
So that is the refraction here. These are refraction. Okay, so this is it. Now you just name it. So let's say N, what is it? NM and NM, should I say M dash? Okay. And this is the original direction, right? So this is the original direction. And when you extend it backward, right, then this is angle of deviation, delta. That's it. You didn't remind. You have reminded. 1 minute extra. Okay, see you after the break.
नहीं वो नहीं अरे पढ़ाई में है ना वो अब थोड़ा सा वो अच्छे से बहुत अच्छे से नहीं हुआ है तो फिर कैसे हो सकता है नहीं इतना तो फिर हम लोग फाइल नहीं बहुत किया है इससे पढ़ने का बहुत ऑफलाइन उनका लेट था ना हमारा बहुत जल्दी हो गया हम लोग का जल्दी हो गया मार्च से शुरू कर दिया स्कूल में वाला हम लोग का 2 मार्च से स्टार्ट हो गया हमारा भी 2 मार्च हमारा सेकंड मार्च से शुरू हो गया था इतना सरप्राइज था उन लोग का एग्जाम चल रहा है स्टार्ट होने वाला है नहीं उनका सब ये आता है उनका स्टडी मार्च उस समय का शुरू हुआ और मार्च से लोग का हुआ एग्जाम मुझे याद है मैं स्टडी का याद नहीं कब शुरू हुआ मेरा स्टडी कब शुरू हुआ मार्च का बीच के टाइम हुआ था ना मार्च के मिडिल बहुत बढ़िया है चाहिए ऑनलाइन का फिर भी पड़ेगा वो तो कितने रहेगा अरे मैंने चार